Hello everyone, Shine is here. I'm going to give you an overview for different tasks in your third portfolio submission, assessment task 3. So here, let's start with the hook assembly. So hook assembly is composed of a hook part, and this part has been detailed in the Canvas shell. You have access to a YouTube channel which tells you how to start making a path, a few sections, and loft the surface through that path using the section. So that part, you have a step-by-step instruction. So what you have to do extra is you need to make a nut bolt. So this one is simply you can import this from your library of the parts. So instead of making this part, you can go to the library, and from there, this is the library of the standard parts. So from the toolbox, you can get into the first adding the standard parts, and then from here you drag and drop. Only all you have to do is to specify the size. In this size, I think that's an M18, which is a metric 18 millimeter, whatever pitch size that is. So not really making a part. This part is a simple one. You can just decide what dimension you want to make. All you have to do is just to make a sketch like this one, and that sketch you extrude that to make the shape, and then you fillet that edge, drilling the hole, and then drilling another hole here, adding a couple of fillets, and that's all. This part can be done using a module from sheet metal forming that we didn't include. I mean, not a unique way of making the very same part. And the last part you have to make, that is a pulley. And this pulley is simply um, kind of hand-free, and it's not complex to make. The difference between this part and what you have done before is first you need to make a sketch. I show you how the sketch looks like. So that is the sketch. I mean, this could be a hand-free sketch. All you have to care is that width should match that of the U shape. Everything else you can just do it like a drawing with some minimal dimensions added to it. And once this sketch is being complete, you let's go back again. So within that sketch, you notice I defined the center line here. So this sketch would be revolved around this axis to make an axisymmetric part, right? So by revolving that, what happens is you get a pulley. And then the remaining thing is to assemble one, two, three, four, and also a pin. So that pin should be fitted in. And from that, you generate a bill of material, which I demonstrate for you later on. So I think that is all about the pulley system. So let's move on to the next one, which is a flange assembly. So this flange assembly, that is the drawing. Maybe the drawing would give you an idea. So here we have two flanges, which are used to make a coupling between shaft on the right hand side and left hand side. And you see that there is a keyhole. Make sure there is no slipping between the shaft and each pulley, and the pulleys are bolted together. So with that pulley system, try to show you the 3D model of that. All right, so again, this 3D assembly is composed of a number of the parts. Um, and then, right, so here, this is exposed of one shaft here. That is a shaft with a keyhole. And then there is a flange. So this flange has a step to make sure it is concentrated with the next step. And also it has a keyway which is all the way through it. And you have a similar flange, perhaps that is a little bit different in terms of the other one has a male perturbation, this one has a female, but that the left hand side is the same. And four holes for fixing the flanges that match together, and also the keyhole is through the entire flange. And of course, there is a second shaft over here, and like what we did, bolts and nuts are being um, just borrowed from the library of the standard part. You don't have to really make anything. So that is regarding that assembly here. Let's go on for the next one, which is a plumber block. And plumber block, this is an open-ended design. I mean, you want to make sure that the center between the fixation point matches because this has to interface with an existing platform. And then the key part here is the bearing. So that bearing has an inner dimension, has a flange on each side. It has a hole for letting the lubrication, just the oil flowing around from in to out. And so these dimensions dictate how the other dimensions, the other parts you have to make. I mean, there's one part here. I show you the part that is the upper cap. So this upper cap has to match the diameter of the bearing, and these are, it's a round face. These are the round face. That's a simple extrusion, and here there are holes, and these holes is for letting oil going in. Again, all these dimensions are open-ended. You can choose as long as it matches this diameter and it matches the lower cap, you will be okay. So the other part you have to design yourself to make this assembly. That is here. So again, the key dimensions here are the distance between the fixation points. And this is the lower cap, has to, of course, match the bearing, has to match the upper cap. So I'm showing you how it will look again. And then we remove some material from below to make this lighter and just consuming less material. I think that is all. Again, a couple of nuts and bolts. You just borrow them from the library of the part. And that is this assembly component. So what else you'll be doing? That is going to the pulley, flange assembly system, plumber block, chest mold. Yeah, I think chest mold, again, there are YouTube demonstrations showing you from an existing chest, how can you make a negative removing the material from a block. So this is actually the second view of the block. And I hope this demonstration helped you with doing your third assessment task. If there is any question, please ask me. We can have more detailed discussion during next computer lab. So make sure you will be there, and I'm looking forward to see you there.